Kotlin Coroutines Deep Dive, Supervisor Job, Error Handling, Channels, and Advanced Patterns. In the previous video, you learned the basics of coroutines. But what happens when things go wrong? What if one coroutine fails? Should all the others stop too? How do you handle errors in concurrent code? And how do coroutines communicate with each other? These are the questions we will answer in this deep dive. We will cover exception handling, supervisor jobs, channels, select, mutex, and real-world patterns. Error handling in coroutines works differently depending on whether you use launch or async. With launch, exceptions propagate immediately to the parent scope. The parent cancels all other children. With async, exceptions are stored inside the deferred object. They are only thrown when you call await. This means you can catch them with a regular try-catch-around await. Understanding this difference is critical for writing correct concurrent code. CoroutineExceptionHandler catches uncaught exceptions in coroutines. Think of it as a last resort, like a global error handler. It only works with launch, not async. You install it on a root coroutine scope or on the scope itself. When a coroutine throws an exception that nobody catches, the handler receives it. Use it for logging and crash reporting, not for recovering from errors. For recovery, use try-catch inside the coroutine. With a regular job, structured concurrency means all children share the same fate. If one child fails, the parent cancels all other children. This is the default behavior. But sometimes your children are independent tasks. Loading news, weather, and stocks for a dashboard are separate operations. If the weather API fails, you still want to show news and stocks. This is where SupervisorJob comes in. SupervisorJob changes the failure behavior. When one child fails, other children keep running. Each child handles its own errors independently. In this example, Child 1 throws an exception after 100 milliseconds. Without SupervisorJob, Child 2 would be canceled immediately. But with SupervisorJob, Child 2 continues running and completes normally. The exception handler logs the error from Child 1 while Child 2 finishes its work. SupervisorScope is the suspend function version of SupervisorJob. It creates a scope where child failures do not cancel other children. Here is a common pattern for loading a dashboard. You launch 3 async tasks for news, weather, and stocks. Each one is wrapped in run catching with get or default. If weather fails, you get null. If stocks fail, you get an empty list. The other sections still show data. This pattern is used in almost every mobile app. A channel is like a queue that connects coroutines. One coroutine sends values, another receives them. Channels are hot, meaning they exist even without consumers. The send function suspends if the channel is full. The receive function suspends if the channel is empty. Always close the channel when you are done sending. Otherwise, the receiver will hang forever waiting for more values. Think of channels as pipes between coroutines. Here is a basic channel example. We create a channel of integers. One coroutine sends values 1 through 5. After sending all values, it closes the channel. The consumer uses a for loop to receive values. The loop automatically stops when the channel is closed. Notice that send and receive alternate. The producer sends one value. The consumer receives it. Then the producer sends the next. This is because the default channel has no buffer. Kotlin provides 4 channel types that control buffering. Rendezvous has no buffer, so send suspends until someone calls receive. Buffered allows 64 elements before suspending the sender. Unlimited never suspends the sender, but can use a lot of memory. Conflated keeps only the latest value, overriding older ones. Choose rendezvous when producer and consumer should work in sync. Choose conflated when only the latest value matters, like UI updates. The produce builder creates a receive channel from a coroutine. It closes the channel automatically when the producer finishes. This is safer than creating a channel manually because you cannot forget to close it. The consumeEach function iterates over the channel and handles closing. You can chain producers together to create processing pipelines. Each stage runs as a separate coroutine. Data flows through the pipeline one element at a time. Fanout means multiple coroutines read from the same channel. This distributes work among workers automatically. Each value is received by exactly one worker. Think of it as a task queue where workers grab the next available task. In this example, 3 workers process 10 items. The channel distributes items fairly. Fanout is useful when processing items takes different amounts of time and you want to keep all workers busy. Fan-in is the opposite of fanout. Multiple coroutines write to the same channel. This merges multiple data sources into a single stream. In this example, 2 producers send values to one channel. A single consumer receives all values. The order depends on timing. Fan-in is useful when you have multiple data sources like sensors, API responses, or user input streams that you want to process in one place. The select expression lets you wait on multiple suspending operations at once. It picks the first one that is ready. In this example, we have a fast channel and a slow channel. Select waits on both and returns whichever responds first. After getting the result, we cancel the other channel. Select is perfect for racing operations, like checking cache and network simultaneously. Whichever responds first wins, and the other is canceled. withTimeout cancels a coroutine if it takes too long. It throws timeout cancellation exception. This is useful for setting deadlines on operations. If the operation finishes in time, you get the result. If not, the exception tells you it timed out. withTimeout or null is the safer version. Instead of throwing, it returns null when the timeout expires. Use withTimeout or null when a timeout is expected and you have a fallback plan. When multiple coroutines access shared mutable state, you get race conditions. Mutex provides mutual exclusion. Only one coroutine can hold the lock at a time. Others suspend and wait their turn. In this example, 1,000 coroutines increment a counter. Without Mutex, the result could be less than 1,000 because of concurrent reads and writes. With Mutex, the result is always exactly 1,000. Always keep the critical section as short as possible. Mutex is different from synchronized. The synchronized keyword blocks the thread. The thread cannot do anything else while waiting. Mutex suspends the coroutine. The thread is free to run other coroutines while one waits for the lock. In coroutine code, always prefer Mutex over synchronized. Blocking a thread wastes resources. Suspending a coroutine is cheap and lets the thread stay productive. Here is a practical worker pool pattern. We create a channel and launch multiple workers. Each worker reads from the channel and processes items. The main coroutine sends all items to the channel and then closes it. Workers automatically stop when the channel is closed and all items are processed. This pattern limits concurrency to a fixed number of workers. It prevents overwhelming the system with too many concurrent tasks. The race pattern returns the first result from multiple concurrent operations. We create a channel for each operation using produce. Then select waits on all channels and picks the first one that completes. After getting the winner, we cancel all other operations. This is useful for redundant requests. Send the same request to multiple servers and use whichever responds first. It reduces latency at the cost of some extra work. There are 3 common mistakes with advanced coroutines. First, not using SupervisorJob for independent tasks. If one task fails, all others are canceled unnecessarily. Second, forgetting to close channels. The consumer hangs forever waiting for more values. Use produce instead, which auto-closes. Third, not handling exceptions in supervisorScope. If you use async without try-catch-on-await, the exception is silently lost. Always handle both success and failure. Let's review what we covered. CoroutineExceptionHandler is your last resort error logger. SupervisorJob lets children fail independently. Channels are queues for coroutine communication. Fanout distributes work among workers. Fan-in merges multiple producers. Select picks the first ready operation. withTimeout sets deadlines. And Mutex protects shared mutable state. These tools together let you build robust concurrent systems in Kotlin. If you like this video, hit the like button and subscribe for more tutorials.